We had an opportunity to hear presentations on BIM content, BIM components, and now we will see examples of various dimensions of BIM. So, BIM dimensions session. And as we know, the higher dimensions of BIM are, very, when we talk of 3D, 4D time schedules, 5D cost aspect, but there are even higher levels like 6D, 7D, using here you will see using BIM to assess the carbon footprint. In this session we have 6 presentations planned. Most of them will be in English, but you can switch over to the channel with Polish translation. In the meantime, you can be asking questions on the chat available at participants panel, and you can also contact experts via networking platform. I do encourage you also to participate in the contest on BIM knowledge. You can win books edited by PWN. When asking questions on the chat, please address them precisely to who is going to answer. And then Maciej Kindler, 5D cost and carbon estimation.
Perfect. Can you see my screen? Just make sure.
Yes, we can see. Everything is
great.
It's great. Yeah.
Great. Great to see you again, Mark. Thank you for the invitation. So I'm Maciej Kindler. I'm a BIM manager, and I specialized in 5D class cost and carbon estimation. And the class stands for the carbon factor unit. And today in my prelection, I will cover the topic of essential of carbon footprint calculation within this process. Some of you may see my presentation last year, but it was entirely in Polish, so I will refresh and remind some of essential points that I make in this presentation. So the first thing, why to invest in 5D estimation? So, and as 5D plus specific. So this streams of work, the BIM management that brings design into a contractor, the estimation and the carbon calculation usually at the moment work in silos. They concentrate on their own scope of data, they create their own structures for the calculation, and because of that there is a limited information exchange. There is a lot of duplication in certain things that are delivered within this process, which means that usually also a lack of clarity. And in most cases this data is not really well structured, and even if it is only structured within an individual silo, but not across wider scope. And bringing BIM into this process brings a natural order into it, because BIM, in its essence, starting from a BIM object, which has a rich data layer with a lot of attribution, is structured from the very beginning. And if you build your processes starting from that point and semi-automate certain steps in it, you will interconnect them and create a more cohesive and more structured database. So BIM in estimating, what does it bring to this process? Normally, you would have some drawings, and from these drawings, quantity surveyors or junior estimators will do measurements from individual sheets and break them down into some groups of activities. They may also break it further down into resources, providing prices for labor, material, plant. It depends on the sector, on the company processes. So they could either estimate it directly from these activities or resources. But because it comes from multiple drawings, it's usually done by more than one person, there is a difficulty in bringing structure into it. Putting BIM up front gives you a structured input coming from BIM objects that can trigger recipes that provide the consistent list of activities for certain type of works, like precast structures, steel installation, in situ, excavations, piling, any kind of finishings, which then could be fully resourced also in a semi or fully automated way. Where in this whole picture lands the carbon calculation on which of these steps? The answer is simple. It can land on any of them. What is the difference between where it lands is the level of uncertainty. So if you do your calculation from resources up, you most certainly be more accurate if you do it from whole activities or entire objects. So what should cover the carbon footprint calculation? In essence, it should cover everything that is related to manufacturing of the product, then construction, then it should cover the entire life cycle, the entire part where the object is in use, and finish with the end of life. It's either deconstruction, demolition, or reuse. It sounds simple, but as you can see, it actually covers a lot of different streams, a lot of data, a lot of aspects, and it is not a very straightforward activity to calculate properly the carbon footprint for an entire object, especially in its whole life cycle. And where the 5D Plus lands in this process, it lands at the very beginning of it, in this phase which is called cradle to practical completion, which, if you think how the estimates work, naturally the estimator put together a price for all the construction works up to the point where the building goes into operational stage. This is what we can effectively do from linking carbon calculation to cost estimation. This doesn't mean you can use this data for the whole life cycle calculation. It only means that to do that, you need to expand the process, you need to add another layer of information to it, and it's not such a straightforward thing. In case of the cradle to practical completion phase, you could do it technically from tomorrow. So, a quick reminder of how the 5D looks. There are multiple tools on the market, such as I2, Costix, DecoOffice, that provides you the connection between BIM model and estimates with resourcing, and you could use any of them. I decided to use an example on a platform called Sterling for a simple reason. It does, up to my knowledge, it's the only platform that does the detailed calculation of carbon footprint according and in line with PAS 2080 regulation, which is a British standard that sets the, that was the first on a global scale to define how to do this. So the 5D, in its essence, you have a model that provides the takeoff of quantities, and these quantities provides our base for the estimation of all the cost items, or maybe not necessarily all, but as many as you can. And all these informations are interconnected. So if you want to review your cost plan or bill of quantities, you can highlight it in the model. If you want to see from the model where it allocates, it all lays down nicely and quickly. So let's go down to the estimation. I will explain the carbon footprint calculation based on the resourcing model, so the bottom-up estimation. And at the very end, I will very quickly show and highlight the difference between this and the object-oriented calculation to show you, to explain why there is a different level of uncertainty for that. So in a normal bottom-up estimation, you would have a cost plan or the bill of quantities, where you have a list of your items that you need to price. And for this, each of these items, you will list all the resources that are necessary to deliver certain types of jobs, including materials, labor, and plant. And these are listed on the bottom, where you can see the summary of total cost and the total carbon calculation that then summarize and accounts for the budget of this in the estimates. So let's look into specific steps of how you calculate the carbon footprint. Starting with class A1 to 3, which is responsible for the manufacturing. So this is the carbon footprint up to the gate of the factory where you ordered your materials. And this number is usually provided by manufacturer, and this is called the embodied manufacturing CO2 rate. And this always applies to materials because any material has to be somehow produced. It's a fairly straightforward, fairly simple calculation because you just take the rate that is provided by manufacturer and you plug it for this type of material. When we go further down, it starts to be a little bit more complicated. So for materials and plants, we do need to account for the transportation to sites. And in case of material calculation, we first need to transform the weight of the material into tons. And from that, we can calculate the number of transports, which will give us the budget. And the last but not least is the operational carbon, which accounts for all the plant and labor and wastage coming from materials. In this case, you need to account for the numbers of travels for all the people to site. You need to provide it with a budget. And you also need to calculate the energy consumption, fuel consumption for specific types of plants and add it to the calculation. So if you go from resources, you can be quite specific, providing energy consumption for individual plants, traveling distances for all the people, and most importantly, embodied carbon rate for individual type of resource. So in case of, for example, in situ objects, you would have an embedded carbon rate for concrete, reinforcement, wood, plywood that is necessary for shuttering, and so on. In case of object-oriented calculation, this is still a valid calculation. However, when you do it, you have a whole object that accounts for formwork, concrete, reinforcement. And when you provide the embodied CO2 rate or the traveling distance, you must somehow level it between different materials and provide it with a higher level of assumption. That is why the accuracy of this calculation is not as good as the accuracy of calculation based on individual resources. I hope this short presentation was informative. And if you have any questions, I'll be more than happy to answer them after the session. Thank you.
Thank you. Thank you very much, Maciej, for the presentation. For all those people who are skeptic about is it really possible to estimate the carbon footprint, maybe with BIM it is possible already.